All right, we have now finally gotten to the last lesson in chapter 1. This is lesson 9. It's called direct variation. And this is kind of a heavy lesson. It's very vocab heavy and it relates to a lot of things we've already done before. So I need you to pay close attention to the vocab and how we're using the words this time and how they might change from how we've used them before. So, new vocab for us this time is direct variation. This is a proportional relationship. So we know it's got to be a proportional relationship. That's going to be important here, which means that our unit rates are all the same. It means that our graph will be linear and pass through the origin. And when those things happen, the ratio of y to x, so we're going to be talking about graphing here, is a constant. We call that constant k. So the equation for a direct variation is y equals k. This deals heavily with graphing. And you'll see a couple examples in a couple minutes. Constant of proportionality. This is your other new vocab word. We did talk about this briefly in the enrichment video for 1.6. The constant of proportionality is the constant ratio we talked about right here. It's that constant ratio k in a direct variation. So the k in our equation is called the constant of proportionality. The proportional relationship itself is called the direct variation. Okay, so work with those words a little bit. Try to use them in a sentence. Let's keep going with our notes. The notes here are a little bit redundant, but it's just to try and reinforce the vocab definitions that we just talked about. So a direct variation is a proportional relationship in which the ratio of y to x is a constant k. We do know that the equation for a direct variation is y equals kx, and k is the constant. K is also the slope of the equation, if we want to call it that. The slope k is also called the constant of proportionality. So it's a bunch of different names pretty much for the same concepts. So this time we're calling it a constant of proportionality. Really, it's that constant unit rate. It's also the slope. Okay, so it's just a new word talking about the same kind of thing. It has to be in a proportional relationship, though. It has to be a graph that is linear and passes through the origin. Okay, keep those things in your head. Steps to finding the constant of proportionality. So we're going to see how to do this if they give us our relationship in a table first. So if the relationship is displayed in a table, first we're going to find the unit rates. Remember, all of our unit rates must be equivalent if this is a direct variation because it has to be proportional. Step 2, the unit rate is that constant of proportionality. So once we have our unit rate, we know what k is. Step 3, we're going to write the equation y equals kx, but instead of writing the k, we're going to put our unit rate number in that spot. And then we will have our direct variation ready to go. Okay, let's see an example problem. This is from your notes. This is question number 1. It says 2 minutes after a diver enters the water, he has descended 52 feet. After 5 minutes, he has descended 130 feet. At what rate is the scuba diver descending? Is this a direct variation? Okay, so you see that I've started by creating a table here. I would like you to do the same thing for number 1, create that table. It tells us only a little bit of information here. We know at 2 minutes, our diver is at 52 feet under the water. And then at 5 minutes, he or she is at 130 feet below the water. So our first job is to see what the rate is that the diver is descending at. So we're going to write our rate. It'll be 52 feet per 2 minutes. Remember, money in the top, time in the bottom. 52 feet per 2 minutes. And we want to find that unit rate. So we divide by 2. And if we divide by 2, we find that the diver is descending at 26 feet per minute. We're going to do the same thing to our other rate, 130 feet per 5 minutes, because we need to see if those rates are proportional. If they are proportional, then this will be a direct variation. If not, then it cannot be a direct variation. So divide by 5 here to find the unit rate. If I do that division, and you can check me on this if you'd like, I get 26 feet per minute. So our two unit rates are the same. That tells me this is a direct variation. Now, if it is a direct variation, we know that this constant ratio here is called the constant of proportionality. So that's our K. So our job is to write this in the equation, y equals kx. So we put y equals 26x, and that is our direct variation equation. Okay, so it's asking us to explain, so I want to quickly write a little explanation here. We can say this is a direct variation because the unit rates are equivalent. The constant of proportionality is 26. And that is enough information for us to have described our direct variation. So don't forget your equation here. Don't forget to give a little explanation about why it is a direct variation, because it is that proportional relationship, and we found our constant ratio. We found K. Okay? I'm going to show you another example. This one is not in your notes. I have a Khan Academy video attached below this link in Schoology, so you should really take a look at that video. That explains this really, really, really well. But I thought that we could get a quick example in here as well. If we do not have a table, but they are giving us a graph, then we can also find the constant of proportionality from a graph. The other way we can look at it, remember our equation is y equals kx. If we divide both sides by x here, that gets the k by itself. And we know that, let me slow down here a little bit. We know that y divided by x is equal to k. So all we did was divide both sides by x, and we found that k is equal to y divided by x. That's that constant ratio. So if we're only given a graph and they ask us to find the constant of proportionality, first of all, it has to be a proportional graph, so it has to be linear and it has to pass through the origin like this graph does. So once we know that, we can seek out any point on the graph that's not the origin. We know that the first is our y number, the first is our x number, the second is our y number. So if we want to find that ratio k, then we just have to put our y number on top and our x number on the bottom. So our y number is 4, x number is 2, and if we simplify that, we get the number 2. So in this case, our constant of proportionality is 2. So if we wanted to write our direct variation equation, remember, instead of writing y equals kx, we'll put our 2 in for k, and our equation is y equals 2x. Okay, rewatch this video again if you need to. There's some heavy vocab in here, but it's nothing that you cannot handle. It's just a different way to kind of express some of the things we've talked about before. The last thing I want you to do, go ahead and finish up all your practice problems for 1.9. Update your flashcards for direct variation and constant of proportionality. Take the Chapter 1 Quiz 4 when you are ready. This quiz is only about direct variation. And then work on that study guide and schedule your Chapter 1 test.